I'd like to welcome everybody today to a discussion of what BGI has done in development of a data science-based approach to automated assessment of aircrew performance in a training environment. My name is Scott Powell. I'm a director at BGI, and I'm responsible for our portfolio of data science and data analysis projects. BGI is a veteran-owned small business. We're in our 27th year of supporting the warfighter, and our focus is merging our key expertise in the areas of data science, software, and system engineering with experienced operational analysts to provide solutions to tough problems facing the warfighter. The challenge presented to us on this project was to determine if technology could be leveraged to improve the process of assessing the performance of aircrew in a training environment in a way that is accurate, consistent, and efficient. That's currently typically a manual process and one or more instructors. That makes it time-consuming. It can be inherently subjective and inconsistent based on who the instructors are that day. It's a challenge because typically they want to be ready to debrief about 30 minutes after knocking off a training exercise, and digging through a lot of data manually it's tough to achieve in a quality way in that amount of time. Our transition target for this is the integrated training facility at Fallon to support both Top Gun, Strike, and the other exercises that are done out there. So to meet that challenge of reducing workload while improving the quality of the debrief, we established a goal to leverage data science technology and create an automated capability that would pull multiple data sources together, but then do more than just present that aggregated data for a human to interpret. We wanted to create interfaces for data streams from multiple sources to identify events of interest like maneuvers, weapon employments, countermeasures, and then collect the parameters that describe those events, store them in a structured manner that links them to that event and highlights learning points by analysis and comparison to established standards. We wanted to do all of this in an architecture that could scale from an individual aircrew training to a large force exercise, and then provide interfaces that would support the instructor intuitively and allow them to capture comments or flag key points, and then have quick and efficient debriefing available and the ability to go back later for more in-depth analysis if desired. So the APA toolkit has been prototyped as part of the Next Generation Threat Systems Analysis and Reporting Tool, or NGTS ART. This is the current prototype implementation. It's not necessarily the only way that it could be implemented. The detection and evaluation logic is being developed in a way that could be adapted to other implementations, and reports can be tailored to other end users. For the prototype, we implemented a dynamic performance assessment model and ran it as part of ART. ART already provides a data collection infrastructure as well as a report generation infrastructure to support exercises that use NGTS to support like debrief and analysis. We integrated the DPAM into that infrastructure. The data is analyzed after the mission is run. A set of data crawlers run through and search for the events and the surrounding critical parameters. And then a report is generated. Every time we find one of those defined events, we generate an entry into a table that defines what the event is and what the measured parameters were. And if they're outside of acceptable limits, that's highlighted in red in this table here. A series of filters are available to the instructor. They can take a look at all the events, only the highlighted events that are outside of parameters, or they can filter down to certain players or groups in the scenario, certain types of events such as weapons employments that they're interested in. Each event then also is assigned a time tag of when it was detected, and when you can click on that tag during the debrief, and it will take you back into the mission replay about 10 seconds before the event occurred, so that you can either review it or you can play it back with the aircrew to review what happened and apply the knowledge that you're getting out of the measurements that are shown in the table. This is a busy diagram, but let's break it down starting in the upper left-hand corner with a training exercise, perhaps including live, virtual, and constructive, or some subset of that, maybe a large exercise with a very significant number of participants generating a large amount of data, which is typically all collected and stored, but often not exploited the way it could be. There may be a human in the loop, an observer, or an instructor that's adding notes to that data. And the first step then is to process it and prepare it for later analysis. The data is parsed. Typically there is some fusing of perhaps time references because it was collected by asynchronous systems or maybe coordinate systems that have to be reconciled. A key part of that processing is the generation and tagging with metadata to describe the data to facilitate searching and identification of data of interest later. That then feeds into the data science platform where machine learning can be applied to go look for trends, to look for events, to collect the data associated with those events so that the events can be evaluated. That's all done based on what's across that bottom layer there, which is your standard doctrine, your requirements, your tactics, techniques, and procedure requirements. Then that data can feeds up into a box that we have labeled readiness assessment, and that actually supports two users. To the left, you see it then feeding back to the aircrew and to the instructor as part of debrief to give them an objective assessment of their performance, help them improve their training. But it also supports, to the right there, analysts who might be interested in how well the tactics are working or how effective the training is being, so that either of those could be adjusted based on the results that they've seen in this exercise. Where is APA today? We've completed the initial prototype, decomposed a subset of the air-to-air timeline, generated some initial tabular reports and some timeline reports. We've conducted one operator advisory group meeting with Top Gun, had reviewed it with them, got some feedback, and we're now into the option phase of our contract, and we're working on enhancing those reports, decomposing the rest of the air-to-air timeline, and also enhancing the underlying decomposition process to move beyond some basic assessment of individual discrete tasks and focus more on decomposing the entire timeline. Gives us more of an ability to look at a kill chain, to look at an effects chain, and find those root causes underlying failures of the tactical mission. So to highlight the key points, the advantages of automated evaluation, it supports a more complete and objective debrief immediately after wrapping up a training exercise, even if it's a large force exercise. The evaluation algorithms that are applied have been designed and validated by qualified instructors based on approved standards. The logic is extensible to other platforms and updated tactics. Evaluation of training effectiveness and aircrew readiness can now be data-driven and quantitative rather than subjective. And the instructors are freed up from a lot of the grunt work of gathering data and reviewing tapes to focus on the key points that they want to emphasize with the aircrew. Where do we think this technology can go? Certainly any type of a training environment where you have student actions that are measured and logged. In addition to aircrew, that could be maintenance trainers, ground troop training, medical surgery sims. While it's best suited to a virtual training environment because everything is by definition instrumented, virtual trainers or instrumented training ranges are certainly also candidates to benefit. So we'll be transitioning this to the fleet over the next year or so, continuing to decompose more of the syllabus, working to ingest data from additional sources, refining the reports, and then conducting our regular OAGs with Top Gun to continue to improve the tool set. If you think you've got an application for this technology, we have a history of forming collaborative partnerships with our customers. We don't like to just hand you a piece of software and a license and a phone number to call for support. We want to become part of your team, give you access to our engineering and operational analyst expertise, as well as a mature baseline of technology from this and other similar programs to adapt to your application, get it developed to your needs, create the reports and the performance models that we need, and then set your team up to use that and be successful. So here's my contact information. If you've seen something here that excites you about the potential for an application you have, feel free to get in touch. Would love to talk to you. Thanks very much.